So today we practice how to sketch the polynomial graph when it is factorized form or factorizable forms. So before we start, we need to understand some aspect. The first one is end behaviors of the polynomials. End behaviors means like both end. The end means x goes to like gets larger or smaller. So means x goes to the infinite or negative infinite. Means this one goes towards the right side when you see this x-axis. So when x goes to the infinite means x goes to the graph. We need to see the right side, the right hand side of the graph, and the negative infinite is left hand side. So we want to know when x goes to the right, how y behave, and when x goes to the left side, how y behave. So this one we call both end behavior. So when you are asked to answer the end behavior, then you need to find out how this graph works when x goes to infinite or negative infinite. There are some rules. We need to see the leading coefficient. So what is leading coefficient? So a polynomial always has the degree. The highest number on the right upper side of the x is the degree. So the highest one is the degree of the equation. So for example, this one, x squared, so degree 2, 5x, x has degree 1, but the polynomial has degree 2. So we understand this is the highest degree. So here, highest degree 4, highest degree 3. So leading coefficient is the coefficient, which is the number attached to the variable. That is the coefficient. But highest degree coefficient means leading coefficient. So here, leading coefficient is positive 1. This one, leading coefficient is 2. This one, leading coefficient is 1. And negative 4, negative 1, 2. Negative 1, something like this. So this one, this is a little bit tricky, but this is a negative 4. So those are the leading coefficient. This is very important to figure it out, how the end behavior works. So when leading coefficient, let me call it A, is positive, then leading coefficient of the end behavior when x goes to infinite, this always defined. Y always goes to the same side, positive infinite. X goes to infinite means towards to the right side. And y goes to infinite means upward. So this means upper right side. So for example, this one, we don't know how to sketch the graph, but we know this graph might start from here. So something like this, we don't know yet. This one also, like this, we don't know. But this one, when A is negative, of course the behavior should be the opposite. So when x goes to infinite, y goes to negative infinite, means lower right side. So this one upper right side. So this is upper right side. So this one lower right side. So here f9 of x, we don't know how the sketch will be, but just at this moment we understand since the leading coefficient is negative, it starts from here. So it may start like, it may start, it may start something like this. So here, lower right side, maybe quadrant 4, and this one quadrant 1. Yeah, we can say that. So this is the leading coefficient of the right side. I'm sorry, the end behavior of the right side. And end behavior of the left side is determined by the degree. So when polynomial is the degree of even number, like quadratic or quartic, like a degree 2 or degree 4 or degree 6, then actually end behavior is the same side. Means y behaves the same way. So, for example, this one, we understand now this is the quadrant 1, like this. Then, since this is degree 4, then when x goes to negative infinite, y behaves same way. So y goes to infinite, like this. So both sides, y behaved in the same way. So this is the even degree polynomials behavior. So like this, for example, this one, leading coefficient is positive. So here, but because this is the degree of 3, so the behavior is the opposite. So the other side goes to like this. So we can say x goes to infinite, y goes to infinite, x goes to negative infinite, y goes to infinite. This is the description of this one. And this one, x goes to infinite, y goes to infinite, x goes to negative infinite, y goes to negative infinite. So this one, we can say opposite. So this is how we can tell the end behavior without sketching the graph. So this is the end behavior. This is the end behavior. So let's practice how to do that. So let's see. So for example, let's just decide the end behavior of those 12 functions. The first one, leading coefficient is positive and degree of 3. So the first quadrant and the quadrant of 3. And second one, degree of 2 and leading coefficient is positive. So first quadrant and second quadrant. And f of 3, this is when you expand it, you will tell the leading coefficient is negative. So quadrant 4, and the same side, quadrant of 3. And f of 4, leading coefficient is positive and degree of 2. So quadrant 1 and 2. F of 5, quadrant 1 and quadrant 2. F of 6, this is degree of 3 and leading coefficient positive, 1 and 3. And f of 7 also, seventh function has degree of 3 and leading coefficient of positive, so behave same way. And f of 8, degree of 4 and leading coefficient is negative. Actually, the number is not important, the leading coefficient, only the sign, positive or negative. We need that just to decide the direction. So this is a negative coefficient. So we start from quadrant 4, and since this is degree 4, it goes to the same way. And f of 9, leading coefficient is negative and degree of 2. So negative means quadrant 4 and quadrant 3. And this one, when you expand it, we can tell the highest degree is 4 and leading coefficient is 1. So quadrant 1 and quadrant 2. Negative, quadrant 4 and quadrant 3. F12, quadrant, this is 2 and degree 3, so quadrant 1 and quadrant 3. So this is how to determine the direction on both sides, which is end behavior. So now let's go to the next one, which is x-intercept. So now we will have a look how x-intercept look like. Like this. Now they have like solution of x equals 1 and 2 and 4. So we need to like put the points on the x-axis where x equals 1 and 2 and 4, and we call it x-intercept. This one and 1 and 4. But what is the difference between them is the first function has its solutions of ones. So it has the solution of x equals 1, but only 1 of 1, and 1 of 2, and 1 of 4. And 8 is 2 of 4, and 2 over 1. So we call this multiplicity. So we call this multiplicity. So now depends on the multiplicity, the way of dealing with this x-intercept is different. So we have 3 different types of multiplicity. So for example, x minus a squared, x minus a cube. It can be more, but anyway, if you understand 3 of these, then all others are just repeated. X minus a. So now we know we put a on x-axis, and all of them a. Here also a. So the first one, just cross like this, or like this, depends on the direction. And the second one, squared, is touch. We call it touch, like this, and or like this, touch. Means that we don't change any sign. Like here, for example, plus 2 negative, or positive to negative to positive, something like that. But here, positive to positive, negative to negative. It doesn't change any sign. And cube, it changes the sign, but there is the point of inflection. We call it inflection point, and it changes some curve shape. So like a little bit wiggle there. So it looks like this, but little bit of wiggle. So like this. So this and this, they change the sign. So we need to cross the x-axis. But what is difference is here cross smoothly, but here cross but stays at the x-axis just a little bit and cross again. So we call it wiggle. And the second one, we just touch the x-axis at the x-intercept and goes again. So those are difference of them. So let's say the first function has 1 and 2 and 4. And we understand the end behavior already. So it starts from here. And it will finish from here. So anyway, we need to go to the x-axis, x-intercept. So here, let's approach it to x-axis and let's decide what we can do. So 4 is only 1. So let's cross over. And we need to go to the next x-intercept again, which is 2, and cross over smoothly, and cross over like this. Actually, we don't understand how much goes up here, how much goes down here, because we didn't learn how to find it yet. So here, and if you want to find the y-intercept, then you can put 0 here, then 2, negative 1, negative 2, and negative 4, then negative 16, like this. So now you can sketch the first graph like this. So, and the f of 3, because it's already factorized. F of 2, actually you can also sketch the graph because it's factorable, but let's go to f of 3. So the third function is 1 and 4, and we understand the end behavior already. So it starts from here and it will end from here. So let's go to x-intercept like this and decide, oh, it's only 1 here. All multiplicity is 1. And next x-intercept, and again crossover like this. And this is a negative 4. Oh, negative 16 again, sorry. And number 8, 1 and 4. And we know end behavior like this. So let's go to the x-intercept and decide. Now we have multiplicity of 2. So we need to touch. So we don't cross over. Just we go back again. But we need to go to the next x-intercept anyway. And go back again like this. This is the graph of the f of 8. This is negative 16. Oh, everything is negative 16. And f of 10, 2, negative 2. We know only 2 and negative 2. We don't know anything else because x squared plus 4 doesn't have any solution. Negative 2 and 2. And we know already end behavior here and here. Let's go to 2. It's only 1. Let's go to negative 2 and it's only 1. So crossover like this. Maybe it may look like the real graph. Maybe like this or like this. But anyway, we don't know. Just the kind of thing is we cannot just understand from this factorized form like this. So this is what we can do at this moment. So let's start here. So here, match each equation with corresponding graph. So just with only the leading coefficient and degree, and sometimes y-intercept, we can decide which one look like. So here, leading coefficient, oh, this should be negative, right? So, then this one, C, because only positive. And degree 4 on both sides, and 1 makes sense. And A and B, this is degree 2, which should be the same side for the end behaviors. So this is C. And this is degree 3, which is the opposite side. So 2 and 4. So this is 4 and this is 2. Like this. So this is the very good tip just to figure it out, which graph look like, which graph is corresponded to which function. So now here, negative 1 and 3. So now leading coefficient is 2, which is positive, and the degree is 4. When you expand them, you will end up with the highest degree of 4. So leading coefficient is positive and degree 4, the same side like this. So let's go to the x-intercept and decide how to deal with this x-intercept. So let's go to 3, and this is multiplicity of 3, so we need to wiggle a little bit like this. And let's go back again, negative 1. And this is only 1. Let's cross over just smoothly, like this. And the y-intercept is negative 54. Yeah, too much. So this is the graph. And this one, possible equation of this graph. Okay, there are two x-intercept, 2 and negative 4, and 2 cross smoothly, and negative 4. 2 like cross smoothly means without any hesitant hesitating. And negative 4 is touching. So now only from the graph, we don't know leading coefficient yet. It must be negative, but we don't know the real number yet. So let's just put it A. And x minus 2, which is 1. X plus 4, which is 2. And there is another the clue here. 0.96. Let's put 0 into x and 96 to y. 96 becomes a, negative 2, and 4 squared. So 96, negative 32a. Therefore, a becomes negative 3. Y equals negative 3, x minus 2, x plus 4 squared. This is the possible equation of this graph. And this one, leading coefficient is negative. This one, it doesn't show anything, but let's say 2, negative 16, because we need another clue. So here, so now we have two x-intercept, which is 0 and 4, and both touch it. So x squared and x minus 4 squared, and leading coefficient is a. So now this is the one. And we have another clue, which I said, 2, negative 16. And because there is no y-intercept also 0, so there is no other clue. So 2, negative 6. So negative 16 is a 2 squared 4. Negative 2 squared 4 means a equals negative 1. Therefore, y could be negative x squared, x minus 4 squared. So here, so we can just match the graph with only degree and leading coefficient, the sign of the leading coefficient, and y-intercept. So degree of 3, okay, it should be the opposite, like this, and leading coefficient is positive. So this is A. And this is a negative, and degree of 2, which is the same side. C. Negative, and degree of 3, opposite side, B, like this. And just few more practice. So for B, 0, negative 2, and 3. And we understand now the leading coefficient is 6, which is upper right side, start, and degree of 3, so the opposite side, end. So let's go to 3. And this side, just smoothly crossover, smoothly crossover, smoothly crossover. So this is the graph of 4B. And 6B, negative 1 and 2. And leading coefficient is positive and degree of 4. Then we understand this and this. So let's go to 2, smoothly crossover. Negative 1, touch. And, degree of 3, sorry. So it should be the other side. And number 7, A, 0. Don't forget this is 0. 0, negative 2, negative 3, and 1. Leading coefficient is positive. So we start from here, goes to x-intercept, and this side. Smoothly crossover, smoothly crossover, cross, everything crossover smoothly. And degree of 4 means the end behavior on both sides is the same side. So makes sense. And number 8, 0, 2, negative 1 over 2. And leading coefficient is negative. So a lower right side, we start from here. So let's go to the x-intercept. So like this. And 2, we have 2, so touch. And goes to 0 smoothly, like this. This is 8B. And 9B is 3 and 1. Leading coefficient is positive. And degree of 4. So goes to 3, touch, goes to 1, touch, and go towards the end. And number 10, degree of 4 and leading coefficient is positive. So the same side. Negative 1 and 2. So goes to 2. But as degree is a 3, so wiggle a little bit. And goes to negative 1. And crossover smoothly. So if you want to find the y-intercept, then negative 24. Yeah, something like this. So this is how to sketch the graph just with x-intercept and multiplicity, leading coefficient, and degree, which is determine the end behaviors.